first, let's have an introduction to hypothesis testing. So the first question which might arise in your mind is, what is a hypothesis? So let's understand this with an example. Like a few years ago, if you remember, Maggi noodles were banned, which is a product of a Nestle company, on the claim that it has excess amount of lead in it. So the government regulatory body, which says that there cannot be more than 2.5 ppm of the lead in any food product, has conducted a test on a sample of Maggi noodles and found that there was an excess lead in Maggi noodles. So what happened is, you can see here like the lead content. So the lead content should be less than 2.5 ppm as per the government regulatory bodies. So what happens is, suppose if like the manufacturer, like which is the Nestle, which produces 1 million packets of Maggi noodles every day, you cannot actually do a survey on that. What they did is, they did a survey on 10,000 packets of Maggi noodles, and that's how they found out that there is excess lead in Maggi noodles. So this is how it becomes a claim, by extracting a sample through a very big population, because the government regulatory body cannot do test on all the packets of Maggi noodles. So they extracted out a small sample out of a very big population, and they made a test out of it, and that's how they reached to a conclusion. That's how they claim that Maggi noodles contain excess lead. So the process of extracting out a sample from big population and conducting a test on it is called hypothesis. I hope it's clear now. We can also look at another example, like a survey being conducted on Edureka employees. The average commute time of an Edureka employee to reach office from home and then going back to the office comes out to be 35 minutes on average. But it's an average, means there are employees which are taking time as 10 minutes also, some are taking time as 50 minutes also, 1 hour also, some are taking just 30 minutes, 40 minutes also. So we found out that we conducted a survey on 100 Edureka employees, and we found out the average commute time to be 35 minutes. So this becomes a claim. This is the status quo. So this is how the hypothesis is being formulated. Now let's understand what is hypothesis testing. So if you conduct a test on this hypothesis, that's what hypothesis testing is. So hypothesis testing, if I frame it, it becomes, hypothesis testing is like used to confirm your conclusion about the population. Through hypothesis testing, you can determine whether there is enough evidence to conclude if the hypothesis about the population parameter is true or not. Now let's understand the null and alternate hypothesis. So we will understand this with an example of criminal trial. So suppose there is an accused which has done some crime, and now judge has to decide whether he has done the crime or he has not done the crime. So there are like now two hypotheses you can see. The first hypothesis is that accused is innocent, he hasn't done the crime, and the second is that the accused has done the crime and he is guilty. So you can see here like there are two opposite hypotheses here. So the first one is null hypothesis, denoted as H naught, which is a prevailing belief about the population. It states that there is no change or there is no difference in the status quo, means there is no difference in the situation, according to which the accused is innocent and he is just a member of the society and he hasn't done anything wrong. Now, second one is the alternate hypothesis, denoted as H1, which is a claim that opposes the null hypothesis, which means the accused is innocent, which brings a change in the situation, a difference in the situation. Now, if you remember the older example which I gave you of Maggi noodles, now the status quo here is, if you remember, the null hypothesis here is that the lead in the food product, means in the Maggi noodles, does not exceed the maximum limit. That is, it does not exceed the 2.5 ppm. And the alternate hypothesis will be lead in the Maggi noodles does exceed the 2.5 ppm limit. That is the maximum limit. Now, if you remember the example of Edureka employee, the survey done on Edureka employees for reaching the office and coming back from the office to their respective homes, means the average commute time, which is taken by them, is 35 minutes. But suppose now the claim is, after some research or survey, we found out that it's taking more than 35 minutes. So now can you please tell me which one is the null hypothesis will be in this situation? Like I will give you the option. So the first option is like employees take an average commute time of 35 minutes, and option B is employees take more than 35 minutes. So you can pause this video right now and you can answer the question in the comment section below. Now you see the outcome of the communal trial example is like the null hypothesis, accused is innocent, and alternate hypothesis is that the accused is not innocent. So if you see here, the rejection of null hypothesis will be like guilty, because that is status quo, there is no change. But if you reject the status quo, which means the accused is guilty. And the second is failure to reject the null hypothesis, which means the accused is not guilty, which means like we don't have the enough evidence to reject the null hypothesis. But remember this thing, that in any way there cannot be a situation where you accept the null hypothesis. The only situation is you don't have enough evidence to reject the null hypothesis. Now we have to understand this important concept, that is formulation of null and alternate hypothesis. So now we will understand how to formulate null and alternate hypothesis. So if your claim statement has words like at least, at most, less than, or greater than, You cannot formulate the null hypothesis just from the claim statement because it's not necessary that the claim is about the status quo. Means always about the status quo. So you can use the following rule to formulate the null and alternate hypothesis. So the null hypothesis always has the following signs like equal to or smaller than equals to or greater than equals to. And the alternate hypothesis always has the following signs like not equal to or greater than or lesser than. Keep that in mind. This is a very important thing. Now let's see an example of Flipkart. Suppose Flipkart claimed that its total valuation in December 2020 was at least $20 billion. Here, the claim contains greater than equals to sign. So the null hypothesis is the original claim. The hypothesis in this case can be formulated as like you can see here total valuation greater than equals to $20 billion, which is null hypothesis, and total valuation is smaller than is $20 billion. You can understand the difference between the signs. I have told you the signs which are used in null hypothesis and alternate hypothesis. You can see the equal sign is there and there is no equal sign in alternate hypothesis. Similarly, in situation 2, you can like Flipkart claim that the total valuation in December 2020 was greater than $20 billion. Here, the claim contains greater sign. So the null hypothesis is the complement of the original claim. So the hypothesis in this case can be formulated as you can see like total valuation greater than $20 billion, which is alternate hypothesis, and total valuation which is smaller than equals to $20 billion is null hypothesis. You can see the difference between the signs. To summarize this, you cannot decide the status quo or formulate the null hypothesis from the claim statement. You need to take care of the signs in writing the null hypothesis. It always has to be formulated using not equals to or greater or smaller signs. Once we have formulated the null and alternate hypothesis, the next most important step of hypothesis testing is making the decision to either reject or fail to reject the null hypothesis. We will understand this with the critical value method. So we take here the example of archery. Now suppose there's a friend of yours named Aviral who likes to brag about his skills of archery, and he told like he has scored 70 in archery. But you doubt his claim because you have a perception that he likes to brag about. So you have this perception of Aviral that he usually brags. So you doubt his claim. So you can see like Aviral's claim here is that he scored 70. That is the status quo, means that is the null hypothesis. So for clearing your doubts, just for the confirmation purpose, you played a match with Aviral. So you played like over 5 games of archery with him, and you find that the average score of game is 20. So which is like less likely to believe actual claim of Aviral if he gets 20 as the average score, because 70 is like far away from 20. So you can like reject the null hypothesis. But suppose the average score of 5 games is like 65. In that case, you more like to believe his claim because it is near to 70. Or if it is more than like even 70, like suppose he got 80 or 90, in which case Aviral is like underestimating himself. So we can see this graph here. So you can say like the status quo is 70. Suppose like the score we can say for the 5 games he got a little lower, like we can say around 55, 60, or say 50 we got. We can say like he scored around 50. Now we have to understand like that we can reject it or not. So there's a critical point where you will reject the Aviral's claim, or there's a critical point above which you will like accept the Aviral's claim. So we say these points as lower critical value or upper critical value. Like suppose if it is 50 or it is 55 or it is until 45, we can say, just for example purpose I'm saying, not for definitive purpose. If the score is 45 or 50 around, so we say like we can actually believe Aviral. But and if it is lower than that, we can say like he was just bragging. Or if he gets the value around like 80 or 90, which is more than 70. So if that is the value, then we'll also like accept the Aviral's claim. We can also say that he might be underestimating himself. So can see this graph first one. In this, see like if whatever the score comes out and red score is come under lower critical value. Suppose you believe that if he gets only 60, below than that you feel like he's just bragging. So he got 50, which comes under lower critical value. So we say that Aviral actually like was just bragging. And suppose you can say like he got around 80 score. So you can say okay, you are believing in him. But if you say like suppose he got score of around 90 or 100, which comes under upper critical value. So you feel like he is just underestimating himself. So in that case, if the research hypothesis means alternate hypothesis value comes under lower critical value, upper critical value, you reject the null hypothesis. And in the similar manner, if these values doesn't come under lower critical value or upper critical value, we say it comes under acceptance region, as you can see here. Like 50 comes under acceptance region, so we accept the Aviral's claim. So in such a situation, we fail to reject the null hypothesis. So these kind of tests where we have like both a lower critical value and upper critical value, these kind of tests we say it as two-tailed tests, which are mostly used in healthcare system. Like suppose there's a medicine in which the paracetamol drug is required, but there's certain amount of quantity is required. like paracetamol, which is used for curing pain and fever of a patient, and we require like 500 ml for curing it. But suppose drug present in the medicine is just 300 grams, it will like decrease the efficacy of the medicine, and it might not be useful for the patient. And like suppose there is a increase in the value of the drug, like suppose there is 700 gram or 10 gram, that can like do side effects to the patient. Maybe it can like cause diarrhea or maybe cause other problems. So which is not a good thing. There is both lower critical value and upper critical value for that. So there should only be 500 grams of paracetamol, not more than that, not less than that. So that's the critical point. Now the second one is lower tail test. So lower tail test and like upper tail test both are there. You can see how their graphs are shown. So these kind of tests are usually used in manufacturing companies. Like we have taken the example of Maggi noodles, where the government regulatory authority found out that the lead content in Maggi noodles has exceeded 2.5 ppm. So there is one kind of test. Like in this, you can see like there was an upper critical value. Like if it exceeds 2.5 ppm, that comes under upper critical value. There are like three kinds of tests in it, as I've explained to you, like two tail test, lower tail test, and upper tail test. So you can see like in lower tail test, the rejection region is on the left side, as you can see on the left side of the graph. And if you see the right side of the graph, you can see the rejection region is on the right side of the distribution. That is for upper tilt. Now that you have an idea of acceptance regions, critical values, low critical value, upper critical value, and different types of tests, let's have a different example to have a better understanding of critical value method. So assume that you are the owner of multiple AC stores. You want to know about the mean demand of AC units per month per store during summer. Till now, you have been ordering 350 AC units per store per month based on the historic demand. But now the meteorological department has said that there will be intense heat waves. So you anticipate that the demand might go up. So you want to check your assumption that the average units required in 1 month will be different from 350 units per store. So in this case, you are assuming that 350 units is the average number of units that are sold every month. When you are trying to visualize it, you use a histogram and the means comes out to be 350 approximately, like you can see here. So this becomes the mean or average of population. So next you will define the null and the alternate hypothesis. You start with the null hypothesis, that is the assumption about the status quo. So you assume that H naught is true, and this implies that your population mean is still equal to 350. In this AC hypothesis problem, the assumption is that the average demand for the AC units per store in 1 month is 350 units. So your null hypothesis H naught states that the mean demand of ACs is 350 units per store every month, as you can see here in the graph. So now that your null hypothesis is clear, the next step is to state the alternative or research hypothesis. So H1 is the opposite of H naught, which means like the opposite of null hypothesis. So it challenges the status quo. This is the assumption that you try to prove, and you should examine all evidence with respect to H1. In your AC sales problem, H1 is that the population mean mu is not equals to 350. You should always examine the evidences with respect to alternative hypothesis, not with respect to null hypothesis. So now you need to formulate the hypothesis. So the first step would be to, in formulating the hypothesis, is that H naught is equals to 350. So there's like no change in the status quo, and H1 is not equal to 350, which, as I explained you, like status quo has changed in alternate hypothesis, which actually is just opposite of the null hypothesis. Now you need to find the critical region for it. Suppose like the sample mean is very far away from 350. Suppose it's around 600. So you can easily say that it lies in the upper critical region, and you can say like you can easily reject the null hypothesis here and accept the alternate hypothesis. Like you can say that the sales is increased. And suppose if sample mean is not very far away, it's like very near to the 350, like you can say like it's around 355. If you say 355, then it's like sample mean is very close to 350. So you cannot reject the null hypothesis, but you also like can't accept cause. So further statistical evidence we will see for it, and then we will decide what we need to go for. So for that we need to do the sampling distribution of the X bar. So as you're working on samples, you will compute the standard error. The standard error can be calculated as standard deviation by square root of number of samples. So you calculate the standard error because you want to know is the value 370.16 has significant distance from the mean 350. So the null hypothesis can be rejected. Now we have the normal distribution of sample means with a mean of 350, and we have the standard error, or we can say that sample standard deviation, which is 15. So now we have to find the critical value through it. So to find the critical value, you need to first specify the probability of an error happening, and we need to like keep this in mind. The probability of an error happening should be the least. So suppose you find out the critical value to be 380. So it's like if you get the sales of more than 380, you can easily reject the null hypothesis. So we can take the significance error value, that is alpha, to be 0.05, which is normally taken as 0.05 only. So we can say through this that the percentage of error happening is 5% only. For 95% of the time, the condition will be right. Means like for 5% of the case, when the you will reject the null hypothesis, when null hypothesis will be actually true, and for 95% of the cases that will be acceptance region. So it's like we fail to reject the null hypothesis in 95% of the cases when it is actually true. So the error won't take place in 95% of the time. So here you can see like there is a lower critical region, upper critical region. There is a ZC value we have to find out for it. So as it's 5% means 0.05. So that will be like divided into half for lower critical region and for half for upper critical region. So for upper critical value, you find it by subtracting it from 1 for area under this curve, which comes out to be 0.975. Then we have to find the Z score for it. That can be found out through this table. Like if you see horizontally and vertically, 0.9750, horizontally it is 1.9 and vertically it is 0.06. So if you add, it comes out to be 1.96. So then you calculate the critical value, like upper critical value and low critical value from the value of ZC. So that you can calculate through this formula, like critical value equals to mu plus Z score into standard deviation of the sample. Okay. So you can see like upper critical value comes out to be 379.4, which is under the acceptance region, and LCV comes out to be 320.6. So as you can see, like the sample mean is less than upper critical value and greater than lower critical value. That is, it is in the acceptance region. So the final decision is that we fail to reject the null hypothesis. Means null hypothesis is true. So we can say that sales will be like equivalent to 350. So now let's understand in a standard form like the critical value method. So after formulating the hypothesis, the steps you must follow for making a decision using the critical value methods are as follows. You can see like you have to calculate the value of Z score from the given value of alpha, mean significance level, which we have taken as 0.05. So like you can see like 0.05 is given as 5% is not specified in the problem. So then you have to calculate critical values like upper critical value and lower critical value from the value of ZC, and finally make the decision on the basis of the value of the sample mean X with respect to the critical values, means upper critical value and lower critical value. I hope this made you understand the critical value method. So apart from critical value method, there's other methods as well to reject the null hypothesis or failing to reject the null hypothesis. So we will look at one of these methods, which is p-value method. So we will now find the p-value for the same AC sales example. So you can see the p-value is the shaded region from the gray area region. So we have to find the like for 370.16 of mean, p-value will be like for like greater than the 370.16. So we need to find the p-value for the Z score 1.34. So if we look for Z table, you can see like the value will be for 0.9099. You can see how horizontally it has been plotted and how vertically it has been plotted for 1.3 and 0.04. We have find the value to be 0.9099. So now for calculating the p-value, we will subtract 0.9099 from 1. So it will come out to be 0.0901. And just because it's a two-tailed test, so we will multiply it by 2 and we get the value as 0.1802, that is 18.02%. And now, so if you see the significance level, which was 0.05, that is 5%. So you can see like p-value is higher than the significance level. So we can now easily say that we cannot reject the null hypothesis. So the final decision is that we fail to reject the null hypothesis. So after formulating the null and alternate hypothesis, the steps to follow in order to making a decision using the p-value method like we have understood in the process is that we have to calculate the value of the Z score for the sample mean point on the distribution. Then we need to calculate the p-value from the cumulative probability for the given Z score using the Z table. So, and the third step is to finally make a decision on the basis of the p-value, like multiply it by 2 for a two-tailed test with respect to the given value of alpha, means the significance value. So by comparing that, we have reached the final conclusion. I hope this made you understand that the p-value method as well, how we can use it for rejecting null hypothesis and for failing to reject the null hypothesis. Now let's understand the types of errors in hypothesis testing which can occur. So the first type of error which can occur in hypothesis testing, we call it as type 1 error, which occurs when the null hypothesis is actually true and we reject it. So if you remember the criminal trial example, so we need to have all amount of concrete evidences to prove that accused has actually done the crime. Suppose judgment for the crime is a death penalty. Just suppose, and if we like, if the judge doesn't get all the proper evidences and he give the judgment as a death penalty, and somehow like those evidences doesn't prove that he is accused, and suppose in reality the accused is actually innocent and he gets the death penalty, that will be a very big error, so which can actually affect the society a lot. So that's the, I mean, say, the density of type 1 error. So we need to keep that in mind, that we need to have concrete evidences to support our alternate hypothesis. So we don't have to reject null hypothesis like that. We need to have proper concrete evidences for it. So then there is a second kind of error, which is a type 2 error, which occurs when the null hypothesis is actually false, but we still fail to reject it. So like type 1 error is denoted by alpha, and the type 2 error is being denoted by beta. So, in the same criminal trial example, suppose the accused has actually done the crime. He is actually a criminal, but we don't have enough evidences to prove that he has done the crime. So, that will lead to type 2 error, because that person can actually, like the criminal can actually again go and do several other crimes, and which can be harmful for the society. That is also like a very grave situation. So, these are, you can say, the types of error we can take place in hypothesis testing, type 1 and type 2 error. I hope you have understood this concept of errors as well. So now that you have a conceptual understanding of hypothesis testing, let's see a case study of Flipkart and how hypothesis testing can be applied in like real-time business and e-commerce business. So let's first have a business understanding and understand the problem statement as well. So in this entire demonstration, you will be looking at an important business metric used in the e-commerce industry, that is the click-through rate, popularly known as CTR. So this is a very important business metric, especially for the businesses that have a website presence or a application presence. So on this metric, we will be making claims and hypotheses and then test them using the concepts that we learned previously. Before getting into hypothesis testing part, let's understand what CTR means and how specifically we are like going to use it in this demonstration. So click-through rate is a pretty generic yet important term in the online marketing industry. In plain terms, it measures the action rate of some entity. May it be a banner ad or a like a homepage for some website, or we can say if there's an ad tech website. So like people, if people will be opening a certain course and applying for it. So those are like action rate of that course of that entity. So now let's understand how the search through rate or CTR can be defined in the search context. So in the case of online search, the CTR is the proportion of searches that was successful when you are trying to compute the search CTR. The relevant formula for it can be given as like total number of successful searches by total number of searches. So what are the successful searches? So I will give you an example for search CTR through Flipkart only. So if you search for, like, we can search for machine learning books. This is the like normal search we are doing, and these are the results. And if I go open a particular search into it, so that becomes a successful search. So now let's get introduced to the industry problem statement that we are going to solve in this entire case study. So suppose that you are a data analyst at Flipkart and you works with a product manager, and that product manager claim that the search CTR has increased from 35% to 40%, and you will be trying to test this claim using the concepts of hypothesis testing. So let's dissect the problem statement a bit further, which will help us in hypothesis formulation as well. So to summarize this problem statement, we can say that the product manager is like claiming that the average population search CTR is 40%. That means out of 100 such searches on Flipkart website, around 40 searches will like result in conversions, means in successful searches. So using this, we can like formulate the hypothesis, means null and alternate hypothesis. So according to the giving claim, as the search rate is 40%, which means null hypothesis will be zero point 0.4, and the alternate hypothesis, which means we are going to challenge the claim. So the alternate hypothesis will be H1 like P not equals to zero point 0.4. Now we have taken this data of 14 days. It's like a sample, we can say. And in this, we can say like on day one, it has like 38% and 37% day two. And but on some days, we have 44% as well, 43%, 41% as well. So for the 14 days data, we have taken for the formulation for further like backing up of our research hypothesis. So now you must be thinking we can like go ahead and conduct the hypothesis test directly on the given data, but think about it for a while. Like which data exactly are you going to test the hypothesis on? Is it the CTR of one day, 1 week, or multiple days? Since the data is varying a lot across all days, how do we ensure that the sample is a random representation one? Because we need to have a appropriate representative sample. Let's understand how to choose the representative sample. So do you think like we need to take the data in a manner like it should show like 40% CTR rate on every day? That's not possible, right? That's not happening. So we will of course take the data where like on some days there will be like 40% CTR rate, there will on some day 35%, there may be some day 45%, and it will vary somewhat. On weekday it will vary, on weekends it will vary, right? So according to given claim, population mean for the given search CTR is 40%, or we can say 0.4. Now the sample we have seen can show variation and may not be exactly equal to the value that is 40%. So it is only that on an average, when you compute the mean CTR for several days, that will bring the search CTR average to be like 0.4, means 40%. So now once you have understood this concept, you need to know which distribution you need to look at. So, like, do you need to see the population distribution or sample distribution, means some different samples? So now that we have understood that we have to focus on sample mean, we will finally compute the sample parameters for the given sample data. So we see that like we can see the CTR it's varying, and we see like for every day there are like normal searches which happen around 500 we can see for day 1 day 2, and then on some day it happens to be 600, some day it happens to be 800. So it's like that. So we can see here the clicks as well. The successful clicks means we can see successful searches, those are 190, 185. On some days it is 2 312, 175 as well. So we can see the total searches are like 7400, and clicks come out to be 2885. So for the 14 days, come out with the average search CTR, that is the total number of clicks out of total number of searches. So which results in 0.39 as the average search CTR. So therefore, like we can say the sample mean comes out to be 0.39 and sample size is 7400. So we can say like we have taken the sample of total searches of 7400. So that brings the sample size to 7400. So next step is we need to compute the test statistic. So now that we have the required sample parameters, we need to compute the test statistic for the given sample. For this, we need the sampling distribution standard deviation as well. So let's say you are given the population variance as 0.24. Now let's go ahead and compute the sampling distribution's standard version. Note that you are already given the population variance of 0.24. So from this and the given sample size, you need to compute the sampling distribution standard deviation. Recall that from the central limit theorem, the formula for sample distributions standard deviations comes out to be sigma by root n. So we can say that sigma square, which is population variance, is 0.24. And as we've already found out the sample size, that is n equals to 7400, thus the sampling distribution standard deviation is computed as sigma by root n, which comes out to be 0.006. So thus we have calculated the sampling distribution standard deviation given from central limit theorem comes out to be 0.006. So now let's go ahead and calculate the test statistic for the sample, which you know will be its Z score. So Z score, as you know, like can be calculated by the following formula, that is x minus mu by sigma by root n. Now for the given problem, we have the parameters as follows. We can say like sample mean is 0.39, population mean is 0.40, that is claimed by the project manager as well. And sampling distribution like standard deviation, we have got 0.006. So substituting the values we get like in the formula, that is x we have 0.39, mu is 0.40, and sigma value is 0.005, means 0.006. We can see the sigma by root n value, that is the sampling distribution standard deviation, that is 0.006, and we get this value as z value, that is 1.756. So this is the test statistic of our sample data. Next method is we have to find the critical region, and we already know like what is alternate and null hypothesis, as well as the population variance, that is 0.24, as well as the sample mean to be 0.39 and sample size to be 7400. That is what we got from the test statistics from our sample data. Second crucial parameter that we need is the level of significance of alpha, that is like how much the results can deviate. So the level of confidence or alpha is the like maximum permissible limit to which the sample can deviate, and for the given test we can take it as 0.05. It's like a industry thumb rule, we can say, like taking the alpha value to be 0.05. But sometimes if you have other situations and conditions that are different from them, then you can have a different like alpha value as well. But here we don't have any such conditions or situations which can affect our significance level. So we have just taken it as 0.05. So using this, we can find the critical region for the given test conditions. So for finding the critical region, you need to use the like value of alpha, means the significance level, as well as the given null hypothesis as well. Since it is a two-tailed test, so we need to have a cutoff range as well. So this cutoff range will be divided into two. So as we have 0.05 as the significance level, that will be divided into two. So that will bring us two like regions on the left side and the right side, that will be lower critical value and upper critical value. So that will be divided into 2 by alpha. So that will comes out to be 0.025. So if your value comes under 0.025 on the left side or the right side, then we can reject the null hypothesis. But as we saw that our value is 0.39, that comes out to even minus 1.756. That doesn't come under the critical region. So it's become easier for us to make the final decision based on the given hypothesis. So now that you have found the critical region, you need to check where your test statistic lies and based on that make the decision. So on the basis of our evaluation of critical region and on the basis of Z score and everything, we have found that we can't reject the null hypothesis. So therefore, we can say that we haven't found enough statistical evidence to disprove the product manager's claim. So this is about the finding the critical region. And now, other than finding the critical region, we have another approach, which is the p-value approach, to do the same as well. So let's go ahead and use that approach as well. So here you will be doing the same hypothesis using an alternative procedure, that is the p-value approach. So this is the most common way of finding the significance of test results in the industry. So technically, p-value is the probability of observing values which are similar to more extreme than the observed value, given that the null hypothesis is true. This metric also enables us to determine whether the given test statistic gives us sufficient evidence to reject or fail to reject the null hypothesis. So let's go ahead and use this approach as well. So when you compute the p-value, you sort of followed an opposite route to the original critical value route. So as we know that p-value approach is more extreme approach of getting the sufficient evidence for rejecting or failing to reject the null hypothesis. So on that basis, we can get more extreme limits. So we can get it like here for 0.39 and similarly on the right side as well. On the left and right side, we have got more extreme limits. So now we can compute the p-value. So for computing the probability corresponding to the given Z score, that is minus 1.756, we get the p-value as a 0.039. Since this is a two-tiered test, you multiply this value with 2 and obtain the p-value as 0.079. Now, since the value is greater than the given level of significance, you fail to reject the null hypothesis. To summarize, the p-value approach also gives us the same result as the critical value approach, which is that either both will reject the null hypothesis or fail to reject the null hypothesis. So with this, we come to the same conclusion as of critical value approach, that we have still don't have proper evidences, like proper sufficient evidences to reject the project manager's claims of click-through rate being increased to 40%. Now that we have learned about the basic concepts of hypothesis testing, and we have learned how to formulate the hypothesis and then make a decision through either the critical value method or through the p-value method. So we will now learn how hypothesis testing is used in the industry and how the concepts which we have learned till now form an important foundation of useful industry concepts. So let's start. So till now we have done critical value method and p-value method, and both of them comes under z-test. But what if I tell you that we won't be able to apply them practically, when we are working in the industry? It happens because if you know the formula, if you remember the formula, it is because the formula for standard error is population standard deviation sigma by square root of sample size n. And in most of the cases, when we handling the situation practically, we don't have the population standard deviation. So we won't be able to calculate the standard error. So how will we calculate the hypothesis? So here comes the t-test. Before understanding t-test, first let's understand t-distribution. So if you see t-distribution's graph is actually very similar to normal distribution. Like you can see here, the normal distribution graph in blue and the t-distribution graph in red. The only difference is t-distribution graph is shorter and a little flatter. So we can say t-distribution is very similar to normal distribution in many cases. For example, it is symmetrical about its central tendency. However, it is shorter than the normal distribution and has a flatter tail, which would eventually mean that it has a larger standard deviation. And at a sample size beyond 30, the t-distribution becomes approximately equal to the normal distribution. So each t-distribution is distinguished by what statisticians call degree of freedom, which are related to the sample size of the dataset. If your sample size is n, the degrees of freedom for the corresponding t-distribution is n plus 1. For example, if your sample size is 10, you use t-distribution with 10 minus 1 or 9 degrees of freedom, you can say, denoted as t9, t base 9. Okay. So smaller sample size have flatter t-distributions than larger sample sizes. And as you may expect, the larger the sample size is and the larger the degree of freedom. So for example, if your sample size is 10, you use a t-distribution with 10 minus 1 or say 9 degrees of freedom. So smaller sample sizes have flatter t-distributions than larger sample sizes. And as you may expect, the larger the sample size is and the larger the degree of freedom, the more the T distribution looks like a standard normal distribution, or we can say the Z distribution. So now the question is when T distribution is used. So the most important use of the T distribution is that you can approximate the value of the standard deviation of the population sigma from the sample standard deviation S. However, as the sample size increases more than 30, the T value tends to be equal to the Z value. Thus, if you want to summarize the decision making in a flow chart, it will look like this. So if you look at how the method of making a decision changes if you are using the sample standard deviation instead of the populations. So if you recall the critical value method, the first step is like calculate the value of ZC from given value of alpha, that is significance level, take it as 5% if not specified in the problem. So to find ZC, you would use the T table instead of the Z table. The T table contains values of ZC from a degree of freedom and value of alpha, which is significance level. So ZC in this case can also be called as T statistic. So practically, you would not need to refer to the Z or the table when doing hypothesis testing in the industry. Going forward, when you need to do hypothesis testing and demonstrations of Excel or we can say of R programming, you would use the term t-test since that is mostly performed in the industry. So all calculations and results of a t-test are same as the z-test whenever the sample size is greater than 30. Now the next one is two sample mean test. So two sample mean tests are divided into two types, that is a two sample mean test paired and two sample mean test unpaired. So two sample mean test paired is used when your sample observations are from the same individual or object. During this test, you are testing the same subject twice. For example, if you are testing a new drug, you would need to compare the sample before and after the drug is taken to see if the results are different. And similarly, for two sample mean test unpaired, which is used when your sample observations are independent. During this test, you are not testing the same subject twice. For example, if you are testing a new drug, you would compare its effectiveness to the that of the standard available drug. So you would take a sample of patients who consume the new drug and compare it to those who consume the standard drug. So we will do a test for it. We can do it in Excel. So Excel is like very heavily used in industry. So this is the data set we have. So we will be performing the t-tests, multiple kind of t-tests in Excel. So Excel is like heavily used in industry for hypothesis testing. So first we can see the one sample mean test. In one sample mean test, we have the commute time of Edureka employees. We have taken the data of 32 Edureka employees, and we can see like how much time the employees are taking for like reaching Edureka office from the respective homes and then reaching back to their home from the office. So we can say like this is the all the data for 32 employees, and this is the hypothesized mean, which is 35. That means we can say that not a hypothesis, but we need to like do our research along with the statistics. We have to come and prove the alternate hypothesis, whatever claim we want to make, like whether it is 35 or it is not. That is just simple. We have previously seen in our like p-value approach and critical value method also from our basic concepts which we have learned. We have learned how to do it. So this was the one sample mean test. Now let's see the two sample mean test paired, which we just talked about. So here you can see that there's a commute time for Edureka employees given for day one and also for day two for the same employees. That's why it is being told paired, because if you see the sample size is same and also of the same person. Like there's a person A, it has a commute time of 27 on day one and a commute time of 23 on day two. Similarly for person B, the same commute time of like 43 for day one and 42 for day two. So now what we have to do is we have to check for whether the average time is equivalent to like we have taken the average commute time to be 35. So if it is coming 35 or not for the day one and day two, and we will find the difference actually. The difference should be zero actually. That then only the null hypothesis will be correct. So how we can do is if you know like there is this option of add-ins. You can search for add-ins in Excel. It is add-ins. You open the add-ins and you will find this option of analysis toolpack. Just select this one and click OK. And when you do that, you will find data option that there's a data analysis pack which has been added. So you open this. So you can see like different types of tests and different types of statistical methods are given here for checking. So here you can see like t-test paired two sample for means is given. This one we have to select because we are checking for two sample mean test paired. So we'll go okay, and we will select the range. So it's here. So range is from here to down. This is the range, and variable 2 also range we will take. Just select here. Okay, and hypothesized mean difference should be 0, right? So we will take 0, and alpha value is 0.05. And output, you can also get the results in a new sheet, but other than that you can also select the output range as well. In that way you will get in the same sheet. The output range we can select, So I will select column E and F. So that is the output range and just click OK. So you got the results here. So you can see like that's just given as pair 2 sample for means, and then mean you can see like there's a little difference in mean for variable 1 and 2. And just a second. So other than that, the variance is also given, observations also, like you can cross check from here like how many samples are given in variable 1 and variable 2, so they are same. And Pearson correlation is given, and DF is also given, T stat is given. Also, like if it is a one tail test or two tail test, in that way p value is also given. So you can see like even in one tail and two tail, both the values are larger than 0.05 and like 0.025 as well for two tail and one test in reference to that. And so we can easily say that if comparing the values of one tail and two tail test are higher. So we fail to reject the null hypothesis, and we don't have enough evidences to reject the null hypothesis. So that is the two sample mean test paired. Now let's come to two sample mean test unpaired. In the same manner, in what the difference in this one is, you can say like this is the commute time of team one. We can say of like this is for Bangalore, for Edureka of employees in Bangalore, and for Edureka employees in New Delhi. Like in Edureka employees in Bangalore, the commute time is 27:43. All these things are given, but it is not related to team two, which is in New Delhi. So it's not of the same person. So that's why we say it as unpaired, because both the values are not related to each other. So in the same manner, we can go and open the data analysis package. So there are like two things. If you are sure about the equal variances, you can select, but right now I'm not sure. So I will select the t-test 2 sample, assuming unequal variance. So we'll just select this, and we will select the variable range. And similarly for second one, we are selecting this variable range per second. So for variable 2, we will select the range. The mean difference will be 0 here. We want in the output range, so we will select the output range as well. So let's select this one. So that's it. So now you can see like the mean variance and everything, like there's a significant difference in mean, and you can see the variance as well and everything. And for one tail test there's a value of 0.01, for two tail test is 0.02. So you can see like there is a significant difference in that, and it's also like lower, the value of one tail test and two tail test are lower than the 0.05 and 0.025 as well. So we can say like we are able to reject the null hypothesis here. So now let's move back to the third kind of test in a t-test, and that is two sample proportion test. So two sample proportion test is used when your sample observations are categorical with two categories. Like it could be true or false, one or zero, yes or no, male or female, or we can say like success or failure. And there are like different other categorical examples. So for example, if you're comparing the effectiveness of true drugs, you would define the desired outcome of the drug as the success. So you would take a sample of patients who consume the new drug and record the number of success and compare it with successes in another sample who consume the standard drug. So we will also see its demonstration in Excel. So this is the data for two sample proportion test we are going to take. Here you can say like commute time for day one is given and commute time for day two is given. And then we have converted that into categorical data. So if the commute time is less than 35, it's 0. And if it is more than or equal to 35, it is 1. So it's like the commute time is given in such a manner that if it is more than 35, it is 1. And if it is less than or equal to 35, then it is 0. The data is given. So here, but how we will gonna make the test, like execute the test here? This time we are not going to use the data analysis package. And there's one more thing called Excel stat, and for that you can like simply search for Excel stat, and you will get it for 30 days. So you can get a free trial of Excel stat, like it is a 14 tray free trial. You can click here and you can get it added to your Excel. So I already have it added in my Excel. So I will just go to Excel stat here. Here, this is the place where it get added. So you just have to start the Excel stat. First time when you click, it just process, and then again you have to go to Excel stat. Then you can just go to test a hypothesis, and that you have to go to parametric tests and select the test for two proportions. So you have to select the frequency for it. Just a second. We'll just cross it. We will first select the frequency. We will first check the frequency for it. So same data for. So here you can see the frequency is 15 and the total sample size is 32. And in this one, frequency is 20 and the total sample size is 32. So we'll again go to parametric test, two proportions, and we can now give the frequency, right? So it is just 15 and this is 32 sample size. This is 20. Sample size is 32. We can also select the proportion as well, but we will be like selecting the frequencies only, not proportions. So because it's easier. So and again we can like select the range for it. So we will just select the range. And we can select in this manner. The range has been selected. Other than that, you can go to the options, and here the hypothesize reference will be 0, significance level will be that, and variance will be there. And in this we have to like select the like proportion 1 minus proportion 2 is not equals to 3, that is the null hypothesis. So we will just select OK. So now you can see like we got the results. So you can see like the frequency is 1 is to 15, sample size 1 is to 32, frequency everything is given, sample size 2 is in the same frequency and the same sample size, same minute is given. Also like if you want to run again with a different frequency, that also you can run, that's not a problem. So if you like want to change the alpha value in the significance level, you can change that and again run, and you can see the difference is given. So we see that the p value is 0.309, which is larger than 0.05. So it is the answer is also given there. The difference between the proportion is equals to 0, and the difference between the proportion is different from 0. That is the alternate hypothesis. But as the compared p value is greater than the significance level, so we cannot reject the null hypothesis. So we got the answer here. So now let's move on to the next test. The next test is A/B testing. So A/B testing is like a direct industry application of the two sample proportion test sample. While developing an e-commerce website, there could be like different opinions about the choices of various elements, such as the shape of buttons, the text on the call to action buttons, or like the colors of various UI elements, or we can say like the copy on the website, or numerous other such things. So often the choice of these elements is very subjective and is difficult to predict which option would perform better. So to resolve such conflicts, you can use A/B testing. So A/B testing provides a way for you to test two different versions of the same elements and see which one performs better. So A/B testing is like entirely based on the two sample proportion test. The two sample proportion test is used when you want to compare the proportions of two different samples. You can use various tools to conduct A/B testing like R or Optimizely, etc. So, but here we will be doing the same A/B testing in Excel. You can like use various tools to conduct A/B testing like Optimizely, Excel, etc. So let's see an example of A/B testing. Like if you know, like there's this media company, like gaming company, Electronic Arts. So when Electronic Arts, a successful media company, released a new version of one of its most popular games, the company wanted to get it right, which is the SimCity 5 game. So if you see the homepage for SimCity 5, a simulation game that allows players to construct and run their own cities, would undoubtedly do well in terms of sales. So Electronic Arts wanted to capitalize on its popularity. So according to like HubSpot, Electronic Arts relied on A/B testing to get its slide page for SimCity 5 just right. So the desire behind this A/B testing example revolved around improving sales. So Electronic Arts wanted to maximize revenue from the game immediately upon its release, as well as through pre-sales efforts. So these days people can like buy and download games immediately. The digital revolution has made those plastic encased CDs nearly like obsolete, especially since companies like Electronic Arts promoted digital downloads. It's less expensive for the company as well, and like more convenient for the consumer. So however, sometimes the smallest things can like influence conversions. Like Electronic Arts wanted to A/B test different versions of its sales page to identify how it could increase sales exponentially. So I'm highlighting this particular A/B testing example because it shows how a hypothesis and conventional wisdom can blow up in your faces. So, for instances, most marketers assume that advertising incentive will result in increased sales. That's often the case, but not this time. So, the original version of the pre-order page, which you can see here, has offered 20% off on a future purchase for anyone who bought SimCity 5. And you can see the option B, so which is the variation which is like created afterwards. The variation, if you see, like has eliminated the pre-order incentive. Like you can see here, the pre-order incentive is given, and here there's no pre-order incentive. So as it turns out, like the variations performed more than actually 40% better. Means option B performed 40% better than the control version, means the original version. So avid fans of SimCity 5 weren't interested in an incentive. So they just wanted to buy the game. As a result of the A/B test, half of the game sales were digital. So do you understand why it works? So the A/B test for Electronic Arts revealed important information about the game's audiences. Like many people who play a popular game like SimCity don't play any other games. They like this particular franchise. Consequently, the 20% off offer didn't resonate with them. If you make assumptions about your target audience, you will eventually get it wrong. So human behavior is like difficult to understand even without hard data. So you need A/B testing to generate data on which you can rely. So let's now demonstrate A/B testing also on the same Excel file. We have the dataset already. So we will just go to A/B testing data. So you can see the data is given here for control group and variable group. So we can say like this is for our Edureka website only, for example. So like someone has reached our website and has opened the course, and if that person registers on the application, so that is where we give them as a 1, and who haven't registered, we give them a 0. That is how it is being labeled. That's how we have labeled the data. Whoever has registered, it's 1, and whoever has not registered but has opened the course, we have labeled it as 0. Let's now check the results for both of them. So let's go to Excel stat, and same visualizing data we can open, not the visualizing. So test a hypothesis, and we can go to parametric tests, and we can do the same test for two proportions. So first let's check the frequency of it. So you can see the total sample size is 2620, and sum is 618. So we will just select it here. We will just copy it here, 618 and 2620. So similarly, we will do the count for variable 2 also, and we got like 601 and the frequency, and the 2380 is the sample size. So we will just go to test a hypothesis, do parametric test, test for two proportions. We will just fill the values here, 618, and this is 2620, this is 601, this is 2380. Select the frequency, and then we will select the range as well, like this range. And other than that, we will go to options, and for this one we will select the proportion 1 minus proportion 2 is smaller than d, which is lesser than 35. That is our null hypothesis, and everything is same like 0 and significance table 5, and then we will just give okay. So results will be here soon. So yeah, as I am using the Excel stat trial version, so it is showing like to use the trial version. So yeah, so you can see here as like test for two proportions we have done, which is the AV test, but you can see like the frequency and everything is given here. Frequencies you can see like 601 out of 2380. And so if you calculate it in percentage for the variable one, that is for control group, there's a 23% success rate, and for the sample size 2, which is like variable group, for that the success rate is 25%. So we found the variance also, like continuity correction, everything is there, data is given, and like 95% confidence interval on the difference between the opportunities we have got. And you can see like the p value is 0.091, which is like the and alpha value is 0.05. So we see like p value is greater than alpha value. So the answer is like we cannot like reject the null hypothesis because like p value is greater. So that's how the A/B testing is done. So now we are like done with all the testings, and we have completed the industry demonstration as well. So we have also understood all the concepts of hypothesis testing, and we have also implemented them on like with the relevance of industry, whatever the test is being conducted in industry. Of those kind of test also we have conducted. I hope the concepts of hypothesis testing